Hello, pre-calc honors students. Here we are with 16.5, working with conditional probability. Now, recall how we found conditional probability. The probability of A given B is the probability of A and B over the probability of B. Remember, B becomes the new sample space. So, during a flu epidemic, 35% of the school students have the flu. Of those with the flu, 90% have high temperatures. However, high temperature is always possible for people without the flu also. In fact, the school nurse estimates that 12% of those without the flu have high temperatures. So let's work this into a tree diagram. So we've got, the thing is, do you start with separating people by the flu, or whether they have the flu or not, or whether they have a higher temperature or not? Well, look at the questions you're asked later on, which is given. It says, school nurse estimates that 12% of those without the flu have high temperatures. So basically, the probability of a high temperature, given that you do not have the flu, is equal to 0.2. So that means, since this is going to be conditioned, we want the flu to be the first thing in our diagram. So kid either has the flu or does not. So let's call that F or not F. And then, at our second level, is whether they have a high temperature. Let's just call that H for high temperature. F was for flu. And this is not H, not a high temperature. And the same thing down here, H and not H. Now we can put in some probabilities. We know that 35% of the schools have this flu, so put 0.35 here for this path. That implies then that it must be 0.65 for the other path, right? 1 minus 0.35. We're also given a conditional probability over here. Of those with the flu, 90% have high temperatures. So if you have the flu, so the probability of a high temperature, given that you have the flu, that's equal to 0.9. So we put a 0.9 right here. That implies that it's 0.1, that you don't have high temperature. Remember I talked about before, the probability of a high temperature given that you don't have the flu is 12%. So we put 0.12 here, and again 0.88. So we're able to fill out our entire chart here. And that's the tree diagram. Now, what percent of the student body have a high temperature? That's here and here. What you have to do is multiply all these out. So you get out your calculator, and what we actually put on the branches of the tree are the conditional probabilities, and then at each leaf will be the product of all those conditional probabilities. So our first leaf here, that is somebody who gets the flu and has a high temperature, that's 0.9, 0.35 times 0.9, you get 0.315. Now somebody gets the flu that does not have high temperature, that's 0.35 times 0.1. That works out to be 0.035. Notice how these add up to 0.35, because that's this case, the flu people. Now the non-flu people, 0.65 times 0.12, and you get 0.078. And then finally, the non-flu people that don't have a high temperature, 0.65 times 0.88, 0.572. Now you should check and make sure that all these add up to 1.00. I believe they do. 0.315 and 0.035 and 0.078 and 0.572, and you get 1. Now, question B, what percent of the student body have a high temperature? So we can look at the high temperature here for part B, and that's the probability of a high temperature, that you have the flu and you get a high temperature, or you don't have the flu, not the flu, and you get a high temperature. So it's the probability of a flu times the probability of a high temperature given that you have the flu, plus the probability of not having the flu times the probability of high temperature given that you don't have the flu. This is just summing up in our notation. We've already done it on the chart here, and that's basically 0.35 times 0.9 to get 0.315. But also there's the scenario of not having flu, 0.65 times 0.12, and that gives the 0.078. And so we add up those two, 0.315 and 0.078, and you get 0.393. So 39.3% of the student population has a high temperature. Now our next question, the probability of flu given that the student has a high temperature. So that's the probability of the flu and a high temperature over the probability of a high temperature. So we figured out this probability of flu and a high temperature right here. That's 0.315 over the probability of high temperature, 0.315 plus 0.078. So it's conditional probability. So we're looking at these kids, the ones with high temperatures, and that becomes our new sample space. So that's why we've got 0.315 over 0.78 underneath. And the new event space is amongst those kids, how many of them have the flu. So we get 0.315 over 0.393, and 0.315 divided by 0.393 works out to be about 0.802. Okay? All right. Flange out.